Good afternoon, ladies and gentlemen, and welcome to APM V-Connect Product Webinar titled What Can You Do Today to Enhance Vessel Efficiency? This session is presented by Lean Marine Sweden and ITEC and hosted by Asia Pacific Maritime. My name is Hairul Burhan and I'll be the moderator and MC for this session. Before we get to the session proper, I would like to highlight some housekeeping rules. First, I would like to encourage everyone to ask any questions you might have relating to the session via the Q&A tab at the bottom of your screen. The speakers will try to answer them towards the end of the presentation and during Q&A. Secondly, we will be running polls throughout the webinar. Please take part in the polls as we will be sharing the results live during the session. Without further ado, let me introduce the first two speakers of the day, Mr. Mikael Laurin and Mr. Jonas Persson. Mikael is the CEO of Lean Marine Sweden and brings with him valuable experience from being both a user and developer of clean tech solutions for the shipping industry. He was also previously CEO of Laurin Maritime for more than 10 years. Joining him for this first presentation is Jonas Persson. He is a sales director for Lean Marine Sweden and brings with him more than 20 years in the shipping industry. Before joining Lean Marine, he was VP of Sales and Projects at TTS Marine. Both of them will present on the topic, how much fuel saving could your vessel get through operational excellence? And without further ado, I would like to invite Mikael on screen to kick things off. Mikael, how are you? Good morning.
I'm just fine, thank you. And you?
Okay, well, I'm happy to have you here. Now, before I hand the screen over to you to start, we do have the first poll to run for the audience. So for those who are joining us at home or from the office, you should see the poll being launched right now on your screen. Basically, the first question being, which step do you need to improve most for increased operation efficiency of your fleet? Is it voyage planning, execution, or post-voyage? Now, I will give you everyone about 5 to 10 seconds to read the questions and the possible answers and to key in your answers. Once that is done, I will close the poll and I will share the results live. And I will ask Mikael for your opinion on this. All right. So we have about another 5 more seconds before I close the poll for those who are still reading. Okay, you have a couple, 3 seconds more. All right. I think with that, I think about 90% of the audience have already submitted their answers to the poll. Let me just end the poll right now and share the results live with everyone. Okay, for the first poll question, the question being, which step do you need to improve most for increased operational efficiency of your fleet? Now, about 71% of respondents mentioned that it is voyage planning, followed by execution at 21%. That's quite far away. And the last one, 7% actually said about post-voyage. Now, Mikael, based on the results that you're seeing on screen, what are your comments on this?
I think that's not surprising at all. I can see that the voyage planning part is where you can really set up your voyage to be more efficient and where you can gain a lot of the operational benefits. So that makes a lot of sense.
Sure. Now, with this, at least you have an idea of what the audience is looking out for. So with that, I hand the screen over to you to start your presentation. All yours.
Thank you very much. Let's see, we can get everything up and running. Here we go. So, hi again, Mikael Laurin, the CEO of Lean Marine. And I and Jonas will talk today about how much fuel saving you could get through operational excellence. And first, let me mention a few things about who Lean Marine are. And we consider ourselves to be maritime experts with a passion for innovation. And our core competence is designing and implementing automated fuel saving solutions and turning data into knowledge. And we've done that already today for over 180 vessels where our systems are implemented and helping our customers save fuel. And that represents about 45 plus different customers that we are working with today. Our calculations show that we save over 160 million kilos of CO2 emissions every year, which is something we are very proud of, and which is something, a figure that we definitely want to increase going forward. Talking a little bit about the operational excellence and improving the voyage, we would like to look at dividing a sea voyage into 3 parts, which you saw already in the poll question, where we have initially the planning part, and then of course the execution part, and then the post-voyage part of the voyage, of the sea voyage. And if we look a little bit more into the different parts, the planning part is of course where you plan your voyage. You set it up for success, hopefully. Part of this is of course doing the geographical planning, the route planning, figure out how to get from port A to port B, and trying to take all relevant factors into consideration. Here you'll have geography. You need to get there safely. You need to avoid anything that's in the way, basically. But you can also look at weather, currents, traffic patterns, traffic regulations, and so on to find the most optimal voyage. Part of that as well is optimizing your speed, making sure you'll be running at the best speed to get to the destination port in time, but also to save on fuel and of course not overtax your engines or anything like that as well. There are a lot of other parameters you can set in order to make the voyage as efficient as possible in the planning phase. You need to plan your cargo stowage to get the right trim. You might have heating or cooling happening during the voyage, and of course the shorter the voyage, the better, or the lower fuel consumption for that. But there are also different heating and cooling profiles that you can work with. And just to get a little bit into how much you can save, in my previous company, we looked at a lot on speed optimization and setting the right speed. And these figures are from a different company, but even so, we saw an MR tanker owner that worked a lot with optimizing speed, especially in the planning phase, getting the speed right, setting the right speed for a specific voyage. And they saw earnings or savings of over $1,000 per day, which is fairly substantial for an MR tanker. So the return on investment, the investment being building a small tool to calculate the speed, optimize speed, and implementing it through the processes was more or less instant. Moving on to the next step, the execution of the voyage, i.e. getting the vessel from port A to port B. Here, of course, we have the navigation, where safe navigation is important, but also, of course, if you can find the right route, you will be saving fuel. What we'll be talking a little bit, or what I will be talking a little bit about today, is going to be more on the speed side, optimizing the speed and optimizing the propulsion during the voyage, and also how you can adapt to changing conditions. Looking at our main product, FuelOpt, I want to explain quickly what it does. It's a fairly simple installation on board, where you get this panel on the bridge. The panel very, very simply has an on and off button. It has 2 main knobs, one for setting the speed, one for setting the consumption, and it has a touchscreen panel with a lot of other options on it. But it's a simple interface which gives the crew better control over the propulsion line and over the speed, over the consumption than you normally have on a vessel, where the main way of controlling the engine and the propulsion line is usually a lever, where you indirectly control RPM or fuel injection into the engine. One fact that you probably are aware of, but I don't think we can stress it enough in this context, is that the faster you go, the more expensive it gets, and it gets more expensive fast. What we mean with this is that if you're running at a constant speed on a voyage, you'll have a certain consumption. If you increase the speed by 1 knot, you will need a lot more, it's a cubic relation, a lot more fuel than you can save by reducing the speed by 1 knot. So running at a constant speed during a voyage or constant fuel consumption is going to save you a lot of fuel compared to going 1 knot faster half of the voyage and then slowing down and going 1 knot slower during the second half of the voyage. So the target during a voyage should be to have a steady and predictable shaft power. And here we're going to look at a small example where we're going to look at a bulk carrier, 200,000 tonner. That's going to, and this is an actual example where we're going to look first how we run it without a fuel up system. And doing that, you can see that there's a blue line, which is the main engine RPM. That is constant more or less during these 5 days, while the speed varies, shaft power varies, and consumption varies. During this graph or this voyage, you can see that most likely the weather is getting a little bit adverse at the second half. So speed is going down, while shaft power and fuel consumption is going up. So you do have variations in consumption, and you do have variations in speed. If you have a fuel up system on board, which this vessel have, you can avoid unwelcome surprises, and you can actually control the parameters you want to control. So this is similar 5 days in operation, where you've set fuel consumption to a steady rate. And here you can see consumption, the lowest of the lines or the bottom line in the graph, and shaft power are more or less constant throughout the voyage. Speed still varies. Main engine RPM varies a bit as well, but not as much. But what you get here is you can get a predictable consumption throughout these 5 days. You will avoid variations, i.e. you will save fuel by not having overconsumption when the weather turns bad and vice versa. So the voyage or the result that fuel up gives is controlled shaft power, i.e. controlled fuel consumption. For this specific vessel, they saved about 225 tons of fuel every year annually in their trading pattern, which is a fairly substantial amount of fuel and CO2 emissions saved. Now, fuel up does another thing as well. And what it does if you have a controllable pitch propeller is that it helps you control both the engine, as we just spoke about, but also the propeller pitch, i.e. the pitch of the propeller blades on the propeller. And fact is that unless you're running a pitch propeller and an engine at full speed and full pitch, you're rarely operating it at its peak performance. So looking at what the system does, it actually goes in and optimizes the settings for each condition. So it takes the engine and the propeller pitch and optimize them for every situation. And we have an example here with a chemical tanker, 14,000 tonner, with a controllable pitch propeller. And here we're going to look at a graph showing speed on the top graph, and the lower graph is consumption. And you can see halfway through how consumption drastically goes down, and that is in relation to fuel up being turned on, the green button being pushed and the system on. In this specific case, what happened is that the weather was good. They were doing about 11 knots. And what happened from the initial conditions, which is here with the propeller RPM and the propeller pitch, is that the engine RPM went down, i.e. the fuel consumption and the RPM went down for the engine, while the propeller pitch went up because the system saw that there was room to increase the propeller pitch and get the engine down. So the savings in this case were fairly substantial, about 20%. And looking at this vessel over time, they saved about 600 tons per year by having the fuel up system and optimizing the propulsion. Going into the post-voyage part, which in the poll was the least important part, that is a lot of administrative work, of course. You need to do your reporting, you need to do your performance monitoring, you want to learn from the voyage you've done and the previous voyages. So this is usually the part where you get the technicians in, you get the operational crew in to look at a voyage, see what you can learn and do the reporting. We're going to have Jonas talk a little bit about that in a second, but I want to mention one other thing before that, and that is that in order to evaluate a voyage, you need to know what's happening during the voyage. And something I always lived by in my shipper operator life was, if you can measure it, you can manage it. Meaning that unless you have proper measurement tool, you can get proper readings, it's very difficult to know what to do and to see the effects of what you do. In my previous job, Laurin Maritime, what we did was that we did a lot of things to save fuel, to get the ships more green, more environmentally friendly. But one issue with that was that we initially relied on noon reports to measure the effects. And the typical savings from these different measures are in the 1 to 10% region, which is a lot of fuel saved. But unless you have proper measuring equipment, you typically going to have a measurement error of 5 to 10%, meaning that a lot of the measures are going to be very difficult to assess. With that, I'm going to hand over to Jonas, who's going to talk a bit more about this. Thank you.
Thank you, Mikael. Let me share my screen. There we go. So, good afternoon, everyone. My name is Jonas Persson, as you already know by now, and as Mikael said, I will continue talking mainly about the post-voyage phase of the journey. So, after having done the journey, you have the opportunity in this phase to study what you have done and learn from it. And for this purpose, we have developed a performance management tool, which we call Fleet Analytics, which is an online tool where we present data collected from the engine, from the bridge in terms of GPS data and wind speed data, and also consumption data from fuel flow meters and so on. And this data can then be used for performance monitoring, for different kinds of analysis, and for reporting. And now I have a problem to switch. There we go. Sorry. And in order to be able to do a proper analysis of your journey, you need a certain amount of data, and you need the data to be uploaded with a certain frequency. So you probably need more than what you would normally get through your manually compiled noon reports sent every day. And also, if you're considering implementing an AI tool, for example, to improve your routes and future voyages, you need even more amounts of data. And the fuel-locked unit is a perfect platform to collect and host this data and to feed it into the AI system. And then fuel-locked can execute what has been calculated in this AI tool. Gathering a lot of data, that is one thing, but actually turning this data into knowledge, that is something completely different. And this is something that we have put a lot of focus in when developing Fleet Analytics. We are collecting all this data. We are washing it. We are treating it in different ways, filtering signals and combining signals, so that we can present them in a way that is easy to understand and useful for different stakeholders within the user's organization. So let's take a look into the tool as such. So in Fleet Analytics, we have a couple of different sections that can be used by different for different purposes. if we start by looking at the fleet overview, this is a sort of a helicopter snapshot, you can say, of your fleet, where you can see where your vessels are located. You can see what speeds they are doing, what the current consumptions are, and so on. Then we have the reporting section, in which you can make your daily reports, your fuel reports, emissions reports, and so on. And if those are done properly, you will automatically have compulsory reports like MRV reports and IMO reports automatically by simply pushing the buttons that is highlighted in green in this slide. And again, we have tried to make this reporting tool fast and easy to use for the crew on board. Then we have a fairly substantial analysis section in the tool, where you can do quite a lot actually. You can study past voyages. You can compare vessels with one another. You can follow up on ship's performance over time, and a lot of other things. And if this is done correctly, if you do your homework in the post-voyage phase, you can use that knowledge in order to improve your best practices and use that into the planning of future voyages, then letting FuelOpt execute what you have planned for, and so on. And in that way, you enter into a positive spiral of continuous improvement. So by investing in FuelOpt and fleet analytics, you will have the tools necessary to achieve significant improvements in terms of fuel efficiency. But as we all know, tools are not so good if they are not used, or if they are used improperly. So it is really important to involve the people working with this. So it's important to highlight that you should educate both the crew on board and the people on board, and that you bring up this subject on the table, that it's being discussed, that you discuss on the results and the facts that you see. And only then you can gain the full potential of these tools. This is super important. So with that, we'd like to thank you all for tuning in and listening to this presentation. Thank you so much. I hand over to you, Haru.
Oh, thank you. Thank you, Jonas, for your sharing. Okay. I think before we actually take in any questions from the audience and move on to the presentation from iTech, I would like to encourage everyone to just key in whatever you want to ask to Jonas or Mikael, and then using the Q&A tab at the bottom of your screen. And then we will have a Q&A session at the end where they will answer all your questions. Okay, so before we move on to iTech's presentation, and I'll introduce you to the gentlemen from iTech, I would like to run the second poll for the audience. Okay, you will see a poll running on your screen right now. The second poll, which is, how does your crew perceive new clean technologies in shipping? Is it they are eager to learn or use new technologies, they have to come up with some suggestions? Or is it they are more training is needed to prove to them the efficiency of the new technologies and show them how to use these new technologies? Or lastly, they do not think they need it. They prefer operating the way that they are used to, which means status quo. Okay, as the first poll, I'm going to give around 5 to 10 seconds for everyone to have a read at the various answers, the various options, and then key in your answers. I will close the poll in about another 5 more seconds, and I will share the results live. All right. So with that, we have about Okay, we have about 75% of respondents have already replied. Okay, so I'm just going to close the poll and I'm going to share the results in a bit. Just hang on for a while. All right. You should see the results of the poll on your screen right now. Basically, the question was being, how does your crew perceive new clean technologies in shipping? And I think an overwhelming 63% said that training is needed to prove to them the efficiency of the new technologies and also to show them how to use these new technologies. Now, I believe we do have some questions from the audience regarding this too. We will be answering the questions towards the end during Q&A. Okay, with that, I'm going to stop sharing the results of this poll and I'm going to move forward to the second segment, which is the presentation by iTech. Let me just share my screen right now. Okay, let me introduce the speaker for iTech. We have two of them joining us today, and we are really happy to have the CEO of iTech, which is Philip Chaabane. Philip brings with him a wealth of experience in senior positions in global technology companies, both large and small. And prior to joining iTech, he was with PowerCell Sweden, where he was responsible for the business and customer development. Joining him for the presentation is Per Svensson. Now, he has more than 30 years of experience in the marine business, working in sales and marketing functions. He is now currently the sales director for iTech. Without further ado, I would like to invite Philip to come on screen and we can start the presentation. Philip?
Hello, and can you hear me?
Yes, hi Philip, how are you?
Very good. Early morning here in Europe. That's a good one.
Yeah, okay. Philip, before I let you carry on with your presentation, I do believe that we have one poll, the first poll from iTech coming up soon. I'm just going to share that poll question with the audience right now. Okay, they should see the questions coming up. Basically, the question being, is barnacle fouling on the hull and in niche areas an issue for any of your vessels? Okay, so we're going to give the audience a couple of seconds to input their answers, and I'm going to ask you for your comments based on the results. Okay, so about 50% of the total audience have already responded, so we're waiting for a couple more to come in. Okay, now the number has jumped to 75% has already responded. Okay, I'm going to close the poll right now. I'm going to share results and I'm going to get your opinion on this. Is barnacle fouling on the hull and in niche areas an issue for any of your vessels? Now, 88% of those listening in said yes, and only 12% said no. Philip, is this really a common thing that you have seen in your various webinars that you have conducted?
Very much so, and that tells us that the presentation that is now to be held will be interesting for those listening to this webinar.
Sure, fantastic. Now with that, I hand over the screen to you. Please carry on with your presentation.
Thank you. So, good morning from Europe. We are delighted to be here to attend this webinar. It's me, Philip, and as mentioned, also Per, who will join in from the middle part of this presentation. We will talk a lot about fouling, hull performance, and most importantly, those small beloved creatures called barnacles. So who are we? We are a biotech company based out of Gothenburg in Sweden who have specialized in trying to solve biological problems related to oceans and structures, boats, vessels being used in the ocean. Barnacles is clearly one of the most important biological problems. We have addressed that kind of problem by a very specific approach. It's highly scientific, it's research-based, and in this case, it comes from the angle of biotech, meaning that the solution was developed through understandings of the barnacle larvae's DNA settings and then Through that knowledge, one could find ways to trigger a certain behavior that would not allow them to settle on a surface. I will come back more to that. It's nowadays a proven technology used in 10 plus anti-fouling products available from the major paint suppliers. Hence, we are an ingredient technology to the main paint suppliers around the world. Several ships, not only several, but several hundred ships are using the technology in various coating systems. And it's a technology that's approved by these very tough regulatory schemes that now are implied in this industry. And that covers Europe and the important markets in Asia, hence making it available for global shipping fleet. To start, a short brief of what marine fouling and biological problem actually is about. This is a generalized scientific view of what's going on any submerged material in an ocean. Anywhere around the world, the same thing happens. Speed of it may be related to temperatures, sunlight, and available nutrition. So in either way, it always starts with a molecular level of organic matter. Then primary colonizers get on, and you're then talking hours. So it's immediate effect of action. Only days later, secondary colonizers come in, and that means microbial communities being built. You start to see slime, maybe even algae, of course. And after weeks, and this is all relating to static condition, of course, submerging and structure and static. After weeks, you have the tertiary colonizers, which is more severe algae fouling, and most importantly, then the macroscopic kind of fouling, which is then barnacles, can be even mussels later on, if you look at months down the line. So any structure, hence in this case, any vessel that is operating and then being idling for several days, weeks, and sometimes a few weeks, will have a significant risk of being caught by severe fouling, and then barnacle fouling would be the most extreme kind, which is also very difficult to wash away. And this is what it's all about, to prevent this to happen. And as mentioned, a few people in the world are so much in love with barnacles as we are, so much that we have taken these in-depth photos trying to understand them inside and outside. And through that, we then came up with this molecule. We call it Selektope, which is then the ingredient technology used in advanced anti-fouling technologies, normally self-polishing anti-foulings. And when this Selektope molecule is available in the coating surface, it will trigger barnacle larvae to swim. It will trigger a hyperactive status, and they will then leave the surface to attach on a competing vessel or another structure. This is a reversible process, so it's not continuously hyperactive. It will go back to its normal condition, but it won't go back to the same surface. So this has been proven very effective. So super small doses of this substance are used in anti-fouling coatings. We say as low as 0.1% of the paint weight needs to contain Selektope to be able to be efficient, which means it's ultra low leaching. Very small amounts are put in, very small amounts are leached out. And it's then approved through the regulatory systems, meaning no bioaccumulation. And we know that it has a tremendous power when, as I said, any structure or ship in this case is idling, which means it has an obvious contribution to reduce the fuel consumption. And as the previous speaker spoke about, hull performance is one part of the equation, and the rest is something that could be dealt with through lean marine systems. But here we're talking the hull and all the biological problems related to that. And as will be seen, that is also related to reduce emissions in general, to sea, to air, and it helps to prevent the continuous spread of invasive aquatic species. Just to give you a more detail on what's going on in the life of a larvae, if you would carry this morning to follow that logic. So there are small larvae nucleus, we call it babies if you wish, all around the oceans. It's a bit of a statistical phenomena where the intensity is at which point, but there's no ocean where they don't exist. And it's normally the same kind of species. So they are always around. They must find the surface at some point to survive. And when they do, they glue on to reproduce. And that's when they glue on, they form this hard shell, which is very difficult to get off. And if you're a private boat owner, you know how hard they are to scrap off, and that they're also quite sharp, so it's easy to cut yourself. This big shell has a tremendous effect on the fuel consumption. So it's about trying to avoid them to settle in the first place, and doing that without killing them. So this molecule we have, the Selektope product, creates a kicking behavior of a high frequency, and it triggers a certain swimming behavior that then forces it to leave the surface. So it interacts with the barnacle larvae during its surface screening activity while it's in the cyprid larvae stage. So the cross in this circle is exactly where the molecule is exerting its mode of action, creating this flight mode. And this is unique, has never been introduced in the marine environment, marine coating environment before. And it's the uniqueness of our company and the research background we have. So how big is this problem in real numbers then? Well, there are many trying to understand this. And if you look on ship hulls in general, we are here in this case showing you an example from ONR, which is a US Navy related research institute, who have made simulations on the effects of barnacle fouling on the shaft power resistance. A surface coverage of around 10% actually generates increased shaft power of 36% to maintain the same speed through water, in this case 50 knots. Yes, it's not a commercial vessel type we're looking at, but it gives an idea of the impact of barnacle fouling even at small surface areas. So it's extremely important to avoid those higher surface areas of severe fouling. That is certainly a key to reduce emissions to air, to save fuel, and to get the best benefit of all those other smart technologies that we have been listening to earlier this morning. There's been some studies around this. So if the former slide was more of a theoretical approach to the problem, we also have tried to dig into the real problem of it. And through the collaboration with Safina Group, we have analyzed jointly a whole number of dry dockings, and then with the focus on the marine hull fouling condition when it came up from dry dock. And this ships that have been in water between 2015 and 2019 that has been inspected. The result shows that 44% of all the surveyed vessels that could be analyzed from a fouling perspective had 10% or more of the surface covered with barnacles. And if we relate them back to the previous slide, that means somewhere around 30 to 40% extra fuel consumption just because of this problem. Now, we have clearly stated that there is a problem to solve, and it clearly is aligned with the answer of the poll leading into this presentation. So it's very important to have the best proper anti-fouling. It's very important that you at least avoid hard fouling, as soft fouling is easier to clean off if you need to. And in some extreme cases, of course, or if every ship would be able to have these kind of anti-fouling technologies, there's a lot of carbon emissions to be saved, somewhere around 100 million tons, or equivalent to $6 billion in terms of money can be spent throughout the global commercial fleet. Obviously, depending on the fuel price, but still it is a significant number. It's likely the difference between profit and loss on many ship types. We also talked about fouling in niche areas, still under the waterline, but in a different part of the ship. So a niche area could be sea chests, it could be bow thruster tunnels. And these are normally identified as risk areas of transporting invasive aquatic species. Of course, there are technical drawbacks of having fouling in these areas as well, but one of the most focused problems right now is their contribution to spreading invasive aquatic species. We have seen that there are about 60 species around the world that are identified to actually come directly from hull fouling and not from the ballast water. So it is a problem. And we see here from this same study that I related to earlier, that sea chest has a tremendous high rating of barnacle fouling. Most sea chests have barnacle fouling, in fact. All ships have some sort of barnacles in this study on their different hull sides, but it's really accentuated on the sea chest. So this is an area where we also think and believe that our technology is making a difference. And we have seen some results from that when paint makers have formulated correctly and been successful in their application. So before handing over to Per, we have concluded that fouling indeed is a big problem, that ingredient technology Selektope has a tremendous effect, and you will see in the slides to come some case studies. And then it's very much obvious that sailing around with 10% or more surface coverage of these barnacle fouling actually only needs 60 days to pay off premium anti-fouling coatings. So applying a premium anti-fouling coating, even at low fuel cost, has a very attractive return on investment, even during quite short period. Comparing them to a poor anti-fouling that would not resist this kind of fouling pressure. And the fouling pressure has been increased lately due to increased water temperatures and so on. So the increased cost certainly is attractive in terms of the return of it, and the knowledge that vessels are idling a lot more now than before certainly puts an interesting light to the case of investing in good anti-fouling technologies, hopefully then containing Selektope. And I now hand over to Per Svensson, who will talk about case studies.
Yeah, thank you, Philip, and good afternoon, everyone. It's a pleasure to be here presenting to you today. You should go back one slide there, Philip. So, as we heard before, there are several hundred vessels out there sailing with an anti-fouling coating containing Selektope, and here is one example. It's an MR tanker, Team Calypso, that was coated in November 2015 with a copper-free anti-fouling coating containing Selektope. And through this time, we're looking at the vessel characteristics. The activity rate has been around 60%. The time when the vessel has been trading, the average speed has been 12 knots, average temperature 25 degrees centigrade. But there have been several long idling periods of 25 plus days. Looking at the next slide, Philip. So this is a recent, in October, underwater inspection that was done. That was then 59 months after the vessel was coated. Up until then, the vessel had only incurred a speed loss of 0.7%. So only 0.7% speed loss over this almost 5 years. And looking at the pictures to the left, the vertical sides and flat bottom, both vertical sides and flat bottom was coated with Selektope containing paint, and there were no barnacles at all. There were on the vertical sides and also flat bottom, lightly covered with slime, and also flat bottom some algae, but there was no barnacles. Looking then to the right, and these are the pictures then before the sea chest's grinds are cleaned. There were some light barnacle there, but only 5 to 10%. So this was a very, very good result. And of course, we all know that those grinds is difficult to apply. So most of the barnacles was actually just on the edges of those grinds. We can move to the next. So when you wish to have a Selektope containing paint, you should talk to your paint supplier. Here you see some examples of paint suppliers and brands products which contain Selektope. There are today more than 10 different products that's available with Selektope, and this is a number that is growing year by year, and it's due to grow in the future as well. So please talk to your paint supplier about Selektope. Next, please, Philip. And then the main takeaways, as we heard, and then we all know also, especially this year, trading patterns have proven to be difficult to predict. There can be long idling periods, especially over a longer time, over 5 years. This independent analysis confirmed that the fouling problem, or fouling is clearly a problem, and it's good to have an insurance if and when you are needing to have idling periods of your vessels. Approximately 30% of all vessels have a barnacle coverage of 20% on the underwater hull area. Independent data shows that anti-fouling coatings containing Selektope delivering improved and longer fouling protection during static periods. And there are several hundreds of vessels out there with Selektope today, and you saw one example which has been in water 5 years now. Regulations, marines, green transition, etc., are one of the key drivers for looking carefully into your anti-fouling coatings and selecting the best coatings. And even at the lower oil prices, the lower fuel prices there is today, there is an attractive return on investment for anti-fouling coatings. Thank you all for listening in for this presentation, and I hand back to the moderator here, Ariel.
Thank you, Per, for your presentation. All right. Okay, guys, before we actually start the Q&A proper, we do have some questions coming in from the audience. I just want to ask the audience for a favor. When you ask your questions, since we have two very separate presentations, do indicate who do you want to ask the questions to. Is it Lean Marine or is it iTech? Okay, that would really be helpful for us. Now, before we bring everyone back, actually, we have one last poll to actually launch for iTech. Now, you should see a poll on your screen right now. Basically, it asks you what influences your anti-fouling coating selection for a vessel. Is it price, technology, environmental impact, vessel activity, trading routes, or all of the above? Okay, I think this will really be helpful in setting the stage for the Q&A later. So please take time, about 5 seconds to input, to give your input, and then I will close this last poll and I will share the results before we actually hit on to the Q&A proper. Okay. Now, a little bit more, I'm looking for a little bit more response from the audience. About 75% have already replied. Okay, a couple more seconds while we hit to around 90% of respondents. Okay, I will end the poll now. I will share the results. Okay, basically, what influences your anti-fouling coating selection for a vessel? Now, a huge majority said all of the above, which is basically price, technology, mode of action, and environmental impact. Now, that I think with that, we can set a stage for the Q&A later. Now, I'm going to invite all of the speakers to come back on screen. Okay, both the Lean Marine team and also the iTech team. Okay, now, okay, before we start, I'm going to encourage everyone again in the listening in, do ask your, input your questions via the Q&A tab at the bottom of your screen. but please indicate who you want to ask it to. Is it the Lean Marine team or the iTech team? Okay. With that, okay, I'm just going to ask the iTech team a little bit about the poll that just ended just now. I think about 65% said all of the above, whereas about 24% mentioned that price is actually quite a huge factor in influencing the anti-fouling coating selection. Now, Philip or even Per, do you see this when you actually deal with your clients? Price, technology, environment impact, which one do they really are more concerned about?
Well, of course, I do understand the result, and we recognize it from other discussions we're having. Coatings is quite a big part of the dry docking cost, so it comes as no surprise. The answer that everything of the above is important. That's what makes this so much more complex task than anyone normally could imagine. It's not that easy to find something that matches all of this. Performing, being environmentally sound, having a super smart technology mode of action, and then also being cheap. That is a challenge, and normally a hen and egg kind of thing. It needs to mature, and once it does, you will probably solve all of this. But we're in a good phase, and it's moving into to several hundred kind of vessels now. So I think we're in a good route to actually find the good mix between all this to make it attractive.
Okay, thank you so much, Philip. Now, talking about barnacles or even all the solutions to fight barnacles fouling, one question that came in was, is your solution Selektope only used in premium anti-fouling coatings only?
Today, that is the case. I would say not only high-end premium, but from low-end premium, if you can use words like that, all the way up to the high-end premium, yes. And it's because it's technology rather than a commodity, right? It's like batteries in cars, right? It is a volume game. It is something that needs to mature a bit before it will find its way down in the mid segment, which I'm 100% sure it will. We just need a little bit more time and see the progress coming in from more paint makers, and most certainly the result from the ships. And then I think we will see how the technology actually goes into the medium segment as well.
Does this Selektope extend the ideal period guarantees offered by the paint manufacturer?
Well, yeah, that's what we see, right? And guarantee or recommendations, in some cases guarantees. You saw from the slide that Per showed there was an anchor with 4 to 5 days idling. That's one way of extending that paint maker product attributes, so to say. So they increased it from 30 days to 45 with adding Selektope to a system. Others are hinting to up towards 50 days of idling resistance and barnacle resistance, which is quite extensive, right? 50 days is a lot. Maybe not in COVID times when ships have been idling all over the place for a long time, but I think it's an attractive step, and then more is to come in that end.
Okay, there are some more questions about fouling, anti-fouling, but I'm going to shift over to the Lean Marine team. Now, one of the questions that was asked was, how do you optimize heating of the cargo, and how much fuel can be saved?
I can answer that. That's not our specialty, just to start with that. But even so, since I've been on the ship operating side before, what we saw there is on a tanker side is there's a lot to be saved actually. Because if you're, as an example, running a vegetable oil cargo that needs heating, you can use up to 12 metric tons per day just to heat the cargo. So if you can plan the heating, usually you don't need to keep the heat level during the whole voyage. You can actually have a span that you can plan. You can have the heat go up and down. This can be a bit complicated, depends on the cargo you're carrying and so on, but there's a lot to be saved by planning so you don't heat fully through the voyage. You can let the initial heat dwindle over time and then heat up at the end of the voyage, as an example, if you're doing caustic soda or something like that, where the discharge temperature is important more than the storage temperature.
Great.
But again, not our specialty, but there's a lot to be saved.
Yeah, I mean, there are a few other questions actually on that. Another question was, in our fleet, there are vessels with different engines and propulsions. Is it still possible to make a fleet level installation anyway? That's one. And how difficult is it to install fuel opt?
Well, you go ahead.
Yeah. Well, we have, I mean, as Mikael presented in the presentation, we have now about 180 installations. We have met most, I would say, combinations of engines and propulsion lines and control systems and so on. So we are bold to say that yes, we have so far not encountered a vessel where we cannot install our systems. Sorry, the second question, Arul.
Was how difficult it is to install fuel opt?
Yeah. Right. I mean, normally the equipment is installed by the crew itself. We can offer also turnkey solutions, but normally the equipment can be installed actually during service, and then when that has been done, we send a service engineer to do the commissioning for a couple of days. So you don't need a dry docking or a very long stop in order to get the system on board.
Mm-hmm. Okay, thank you for the sharing, Jonas. Now back to iTech. All right, there is a question that comes in from this guy called Mr. Uchuk Kutsuri. Basically, he's asking, for slow steaming or slow speed operation, are anti-fouling systems different or the same for medium speed?
I would say they need to be tuned in terms of polishing rates. Now, this is the technical specialty of paint makers to adapt the coating to the vessel. I am sure that when they specify the coating, they need to take into account the speed of the vessel. That's one answer. The other angle of that is when you slow steam, your speed through water is lower, obviously, which means the contribution to the overall friction is higher from the hull rather than from the waves, which makes it even more important to stay clean from hull roughness, meaning fouling. So that's another aspect. And of course, at slow fouling, less things will fall off, so you will have a bigger problem. So I would say slow steaming, go for really good anti-foulings as well. Don't think that that's a way out of that problem. That's my answer.
Okay, sure. Now, talking about barnacle fouling, I mean, is it only an issue if the vessels are set still idle for a few months or more, or that's not the case?
No, well, as I said, yes, static, when a ship is static, anchor, yes, then the problem starts with barnacle foul. They are not quick enough to swim and attach on a moving ship, certainly not if it's like 5-6 knots or more. So yes, the static period is the troublesome period for fouling in general. I should say that even slime and so on can grow on when the ship is moving, but barnacles is much more the problem when you are static. And as I mentioned on the slide, it's only weeks before you may have problems. You don't need to wait months, or the risk is actually obvious already a week into the anchor scheme.
Any particularly bad areas for barnacle fouling that you have seen so far? Where are the danger zones?
Yeah, there are several what we call barnacle paradises, right? Areas where they are very happy to be and they're very active. And of course, they may define the typical troublesome hotspots. And those could be Tokyo Bay, it could be Singapore area where you have nutritions, you have sunlight, you have quite high temperatures. We have seen large issues at new buildings, maybe not upstream rivers in China, but for those yards in the coastal areas, where global temperatures have actually increased, the ocean temperatures, meaning the activity of fouling has increased, and it's much more difficult now to survive an outfitting period than before. And actually that is an area where Selektope is having a very high penetration at the moment. It's a new building area because you need to keep away from fouling, not only outfitting, but also the years after. And the combination of that is exactly what Selektope is doing the best.
Fantastic. Now, for the audience who wants to know more about Selektope, please get in touch with the iTech team. I believe they can share their contact details at the end of this Q&A session. Now, we're going to jump back to the Lean Marine team. A couple of more questions regarding more of the big data or AI. Okay, now, the question that came in, what effects do you think big data or AI have on the shipping industry? Now, it's a very generic question. How does fleet analytics exchange data with other systems?
That's a very good question, actually. It's a two-tiered question. So the first thing, how does big data affect the shipping system? Well, what big data enables is that it enables you to build predictive models. So basically, you can look at a lot of factors at the same time and get more information out from the data than you can with the lower frequency data. You, of course, need to take care of the data, and you need to turn it into something useful, turn it into knowledge. But what you can do is you can actually enhance your prediction models. So as an example, a weather outing system based on classical data is not going to be as good because it won't be able to look at this specific vessel, how it reacts in waves, weather, wind, fouling, whatever. And this is where I think you can get a lot. And we looked at saw in the survey that the planning is what a lot of companies are focused on. And that's where you need to have the big data to feed into that for your specific vessel or your specific fleet to be able to learn. So I think that's going to be the big effect of the big data. First, being able to measure where we're getting to, but the second step is going to be able to predict your voyages, to be able to do better planning, basically.
Fantastic. Okay, well, great. Well, we have almost, in fact, we have actually reached the 1 hour mark where I'm being asked by my team to actually stop this session right now. Anyway, for those in the audience, I believe you do have some other questions coming in. I'm going to ask Philip, Mikael, Per, and Jonas to say a few words to the audience, how maybe you can, how they can get in touch with you, and why they should contact you for whatever reasons. I'm going to give everyone about 30 seconds each to actually do a summary of what you want to say. And after that, I will end the seminar. Okay, let's start with Philip.
Oh, sorry. Here I am.
Yep.
Can you hear me?
Yep.
Yep. First of all, you can get in contact with us through the links in this presentation. Our web pages, selektope.com or itech.se is a good places to go. We are very happy to have the chance to be on here. We certainly can contribute with questions not only relating to the molecule itself, our product, but also to paints in general, as we do have quite some experience on paint formulations, although we don't sell paints, of course. My final remark is the beauty of having Lean Marine and iTech in the same webinar, some may think that's a strange setup, is that it's two areas separately on the ship that together contributes a lot to the future needs of reducing emissions. Lean Marine does it on board on the propulsion system, the planning, the post-voyage analysis, and the learning from that. And you still need then to take care of your hull, where iTech comes into the picture. So that's the logics. And I think that's two proven technologies, quite simple to install and get your hands on, and off you go with quite remarkable savings. So it's a holistic view, which we hope everybody understood and can continue to enjoy through continuous dialogues with these two companies. Thank you so much.
Nicely said, Philip. Now, how about you, Per? Any last words for the audience?
Yeah, thank you very much for listening to us here. It's been a pleasure presenting to you today, and I echo Philip, encourage you to get in touch. Links in this presentation, our webpage, selektope.com or itech.se. So please get in touch and we will be happy to present more for you. Thank you very much.
Thank you, Per. Now over to you, Mikael.
Yes, I'm going to start by answering the second part of the last question that I never got time to answer. And that is, how do we connect to other systems?
Yes.
And the answer is, we believe that all systems need to be social systems that can take data in from other systems and transfer data to other systems as well. And that's also how we at Lean Marine want to do business. So please give us a call. You have the contact details, I believe, in the presentations. Otherwise, you'll find them at leanmarine.com. We also believe that being social means connecting and working together with companies like iTech that have similar goals to us to reduce environmental footprint of shipping. So I think doing things like this together makes a lot of sense for us.
Fantastic.
Thank you very much for all your time.
Thank you. Jonas?
Not really much to add there from what Mikael said, but yeah, there are lots more to be said about our solutions. So we encourage you to get in contact with us to discuss your specific needs for your specific vessels. And yeah, Mikael already mentioned how to get in touch with us.
Great. Now with that, I would like to end this session. Thank you so much to everyone here, all the speakers, for taking time out of your busy schedules, and also for those who are listening in, whether you are from the office or from home. Hope you have found this webinar to be useful. Now, if you need to get in touch with any of the speakers, feel free to do so. I'm sure they are willing to answer all of your questions. And if you need their contacts, if you don't have it online, you can't find it, just give me a call, give me a contact. I will be very, very happy to share that with you. With that, thank you so much once again. And I hope you have found this webinar to be very, very insightful. Thank you so much, guys, and bye-bye.